Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem pair with given sum in a sorted array. What the problem is saying is will be given an integer target and an array air. You have to find the number of pairs in array with sum which sums up to the target. It is given that the elements of the array are in sorted array. Okay. So let's quickly see. So here is a given example. Okay. And what the problem is saying is the array will be sorted. Okay. Now what we want to do is we want to find out all the pairs whose sum is equal to the given target. So what are those pairs? One of the pair is minus 1 and 7, right? Minus 1 and 7. Okay. Then another pair is minus 1 and 7 again. There are two minus 1. That is why we have to consider twice. And if you see, the sum of this minus 1 plus 7 is 6, which is equal to the given target. Another pair is 1 and 5. 1 and 5. Another pair is 1 and 5. Again, 1 and 5. So these are four pairs, right? These are four pairs whose sum is equal to the given target, and hence you have to return the count 4. Okay. So this is the ask. Now, how can we solve this problem? So let's first see the naive approach. Okay, so what the naive approach will be for I equal to 0 to n minus 1. Okay, and another follow-up will be j equal to I plus 1 to, sorry, j equal to I plus 1 to n. Okay, so these will be the two follow-ups. Okay, which will iterate to all the possible pairs. Okay, and we're going to maintain a count variable, count equal to 0. Okay, and we're going to have a sum equal to a of I plus a of j. Okay, and we're going to check here. If sum equal to given target, then increment count. Okay, this code will give you the count of all the possible pairs whose sum is equal to the given target. Okay, this will do the job, but what will be the time complexity here? It is going to be O of n square. Why? Because of these two follows. Okay, so we want to find out. So this approach we cannot uh, use to solve the problem because the time complexity is more. This is a naive approach. So we have to find the better approach. Okay. So what that better approach will be, let's quickly see. So let me erase this part, or let me have this. Let me delete this part. Okay. So let me write this again. Minus 1, 1, 5, and 5 and 7. Okay. So what we're going to do, since we are given that the array will already be sorted, right? So we are going to solve this problem using the two pointer approach. So we're going to have two pointers here, L and R. Okay. Now what we're going to do, we are going to take the sum of the elements at the position L and R. Okay, sum equal to R of L plus R of R, right? Now this minus 1 plus 7, minus minus 1 plus 7, right? Plus 7, which gives you 6, which is equal to the given target 6, right? Which is equal to the given target 6. Okay, and hence we have found one pair. So we are going to increment. Initially it will be 0. We are going to increment it to 1. Now what we're going to do, we are going to take a next left pointer as well. Whenever the sum matches the target, we are going to take one next left pointer, and we're going to check with the previous element. Okay, if it is same, that means we still have the pair. We have got another pair. Why? Because for example, if this minus 1 and 7, right, we have seen this, right, minus 1 and 7. So this will also be the pair, another pair, right, minus 1 and 7, because of minus 1 coming twice. Okay, and hence we are going to check. We're going to take the next left pointer. If it matches the previous element, then we are going to increment a count as well, and we'll keep on incrementing next left and until it matches the previous element. Okay, now here next left, right, we incremented next left. Now it didn't match the previous element, so we're going to break out of the while loop. Okay, and so the count here will be 2. Now we are going to break out of the while loop and we'll decrement R as well. Just be with me, you'll understand. Okay. Now what is the state? Let me write this. Let me write this here. Minus 1, 1, 5, 5, and 7. So our L is still here. We have decremented our R, right? We have decremented R. Okay. Now I'm going to take sum again of these two elements, right? Which is minus 1 plus 5. It is 4, which is less than the target 6. So what we're going to do in this case, we're going to increment our L pointer, right? Again, we're going to take the sum minus 1 plus 5, which is 4, which is again less than 6. We're going to increment our L pointer. So now our L pointer is pointing here and R pointer is pointing here. So we're going to take the sum 1 plus 5, which is 6, which is equal to the given target. And hence we're going to increment the count. and we'll take a next left pointer here, right? Which will point at this particular location. We're going to check, we're going to compare with the previous element. No, it does not match. So we are going to break out of the while loop and we'll decrement our, we are break out of the while loop and we are going to decrement our R as well. So R will now be pointing here, right? We'll take the sum again, L plus R, okay, which will be again equal, okay, which will again be equal. So we are going to increment our count, okay, and we're going to have a next left pointer, but here the condition will be next left pointer should be less than R, which it fails, and we're going to break the while loop, okay, we're going to break this while loop and we're going to decrement our R. Now again, L and R both are pointing at the same element, so this, the outer while loop will also break and we'll return our count variable, okay. I hope you're getting the intuition. I think it will be clear with the code. Okay, so let's go to the code. Before going to the code, I'll just request you, please subscribe to the channel, like the video. Okay, as I've tried to make it very easy for you. So let's quickly take two pointers, L equal to R. So first I'll show the Java code followed by C++. R equal to R dot length minus 1 while L is less than R. Okay, and sum equal to R of L, we'll say, plus R of R. If sum equal to target, we'll have a count variable as well, count equal to 0. So we're going to first increment our count. Next, we'll take our next left pointer as well. Next left equal to L plus 1, we are going to say, right? And we are going to check here, next left should be less than R. And then R of next left, if it is equal to R of next left minus 1, right? That means we have duplicate elements, right? We have duplicate elements. So in that case, we have found out again the pair. We are going to increment count and we are going to increment next left as well. Okay. So once the element don't match, so we will break out of this while loop and we are going to decrement our R as well, as we have seen in the example, right? And then what we are going to do here? Else if sum is less than target, that means we want to increment the sum in order to match the target, right? So in order to increase the sum, we'll have to increment the left pointer. Okay. If the sum is greater than the target, then we have to decrease the sum. So we are going to decrement our R pointer, right? And at the end, we're just going to return count. This is it. Let me compile this. We'll discuss the time complexity as well. So yes, so the time complexity here it will be O of n because we are iterating to the array once. Okay, the array is already sorted, so so we don't have to sort again, and hence the time complexity will be O of n. The space complexity is going to be O of 1. Okay, so the test is up passed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. So it's almost same, no difference. The code is almost same. 99% is same. Only difference is here, arrow of size, right? There it was arrow of length. That's it. I'll attach the code in the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.